Hello everyone, welcome to Cracku DILR series. In this series, we are covering 100 plus CAT level DILR sets for CAT 2026, covering easy, moderate and hard difficulty levels. In this video, you will get one complete DILR set and the PDF will be mentioned in the pinned comment. Download it before you start. Pause the video, try solving the set by your own and continue to watch the video. If you're preparing for CAT 2026 and want a serious DILR practice, then this series is for you. And if you want more DILR sets, we have thousands of them. It's very simple, just go to Google and search Cracku DILR sets.
In this question, we are told that mathematicians have a number called LRDI number. This is based on the papers that they have written and the co-authors that they have. So there is a famous mathematician called LRDI and he was given the LRDI number of 0. And anybody who has co-authored a paper along with LRDI will have an LRDI number of 1. For people or for mathematicians who have not written a paper with LRDI, now there is a way to calculate their specific LRDI number. That is, they look at all the papers that this mathematician has written and they'll calculate all his or her co-authors and they'll find the minimum LRDI number of all the co-authors. If the minimum LRDI number of the co-authors is say y, then this particular mathematician will have an LRDI number of y plus 1 and it will continue to go on. Now there are some mathematicians who are not connected to LRDI in any way. They have written papers with other co-authors who are also not connected. So they are in a separate set of people. All their LRDI numbers will be treated as infinity. They are supposed to be very high. So this LRDI number will basically give how close a person's research is to Paul LRDI. Now this is basically the background of the set. In addition to that, we have been given some clues. We have been told that there is some mathematical conference in which 8 mathematicians A, B, C, D, E, F, G and H have attended it. And we are given some clues which will help us in figuring out what are their particular LRDI numbers before the conference, they change during the conference, and what will they be after the conference. So let us try to go ahead and look at the clues and then solve them. So initially, let us first write down the names A, B, C, D, E, F, G and H. Now if you see at the beginning of the conference, this is at the beginning. This will be at the beginning and there are two changes that happen. One will be after day 3 and the other is after day 5. So this is at the beginning. This is after day 3 and this is after day 5. Initially we are told that at the beginning of the conference, A was the only participant who had an infinite LRDI number. So as we have discussed earlier, A has not co-authored with anybody who has an LRDI number. He was in a separate set of people. So the LRDI number of A is infinity. All the others have finite LRDI numbers. So they are related to Paul LRDI in some way. We are also told that nobody has an LRDI number less than that of F. So let us call the initial LRDI number of F to be, say, F. Now we are told that on the third day of the conference, F co-authored a paper jointly with A and C. So once you co-author a paper with A and C, we know that F has the minimum LRDI number. So his LRDI number will not change, but the LRDI number of A will definitely change because initially it was infinity, but now he has written a paper with F, so his LRDI number will become F plus 1. Now we know that the LRDI number of C might also change because he has co-authored a paper with F who has the least LRDI number. So there are two cases over here. Case 1 is if the initial LRDI number of C is F plus 1 or above, then his LRDI number will become F plus 1. But if say initially the LRDI number of C is F itself, then his LRDI number will remain F. So suppose if the LRDI number of F is say 5 and the initial LRDI number of C is say 50. Once he co-authors a paper with F, his LRDI number will become 6. Or even if it was 7, once he writes a paper with F, then it will decrease to 6, which is 5 plus 1, where we are assuming that the value of F is 5, just as an example. But if say the initial LRDI number of C was 5 itself initially, then just by writing a paper with somebody else who also has a LRDI number of 5, the LRDI number of C doesn't change. So now there are only two cases possible. Case 1 is the LRDI number of C is F, it was always F and it will remain F after this paper is written, or it is F plus 1 now because earlier his LRDI number was quite high. Now let us look at what else was given. Now, after writing this, the Erdos number of the 8 mathematicians, the average Erdos number of the 8 mathematicians becomes 3. That is, after writing the paper on the third day, the total Erdos number of the 8 mathematicians is 24. The Erdos number of B, D, E, G and H, that is the remaining 5, remains unchanged. This would imply that they have not written any paper either with A or with C. Because if the Erdos number of A and C have changed, then it is possible that the Erdos number of B, D, E, F, E, G and H also get updated, because the Erdos number of these two guys have decreased. There are many possibilities there, but at least it is given to us that we can ignore the changes in B, D, E, G and H, that is the remaining 5 people. It is also told that no other co-authorship amongst any 3 members would have reduced the average Erdos number of the group to as low as 3. Now this is a crucial clue. This will help us in understand what the Erdos number of C initially was. We know that A had the highest Erdos number before the conference started. He had an Erdos number of infinity. So his Erdos number has definitely decreased to F plus 1. But what about C? It has been given to us that if we pick any other set of 3 people, the Erdos number would not be as low as 3. So this would imply that after A, C was the second highest Erdos number before the conference started. Because if, say, there was another person D who had a higher Erdos number than C, then the triplet F, D and A, if they had written a conference paper, if they had written a paper, then the average would be lesser. That is, if you are considering that D had a higher Erdos number than C, and if D writes a paper with F, and his decrease in the Erdos number would be much higher, therefore the average would be lesser than 3. But because we are told that there is no other triplet which is possible, it would imply that C has the second highest Erdos number after A. That A has infinity and has the highest Erdos number before the conference is a given. Now again, there is one more thing that we'll have to look at. This doesn't mean again for sure that the Erdos number of C is F plus 1, because there is one case that is possible, which is that all the 7 members had an Erdos number of F before the conference started. So all of them will remain F even after C, A and F have written a paper. But the next clue over here tells us that at the end of the third day, 5 members of the group had identical Erdos numbers and the other 3 had Erdos numbers which were distinct. So the trivial case in which 7 of them had F, that is C, D, B, all of them had the same Erdos number, is contradicted. So now we can say for sure that at the end of the third day, that is after A and C have written a paper with F, the Erdos number of A is F plus 1, the Erdos number of C is also F plus 1, the Erdos number of F remains F, and now the clue that is given to us that at the end of the third day, 5 of them had the same Erdos number and the remaining 3 had distinct numbers, will help us in solving more or getting more information. Now if we know that 5 of them had the same Erdos number and 3 of them had distinct numbers, the 5 same numbers have to equal F plus 1, because we know that A and C had F plus 1. So the only possibility of the number which is being repeated is F plus 1. So 5 of them had F plus 1. The 6th one is F who has F. The 7th and the 8th, let us assume, are A and B. Now we also know that the total of the Erdos numbers is 24. This will help us in understanding that 5 into F plus 1 plus F plus A plus B is equal to 24, or 6F plus A plus B is equal to 19. Now clearly F cannot equal 3 or more, because if F is 4, for example, 6F will become 24. If F is equal to 3, then A plus B has to equal 1. This also we know is not true, because the F is the smallest number in the group. So if A plus B is equal to 1, it would imply that A and B are 1 and 0. They can't be less than F, so F cannot even equal 3. So the only possibility is that F is either equal to 1 or F is equal to 2. Let us first assume that F is equal to 2, try to solve it, and then we will come to F is equal to 1. If F is equal to 2, 6F will equal 12. So A plus B has to equal 7, because 6F is 12 and A plus B is 19 minus 6F, so A plus B is equal to 7. Now the only possibility is A is equal to 3 and B is equal to 4. or A is equal to 2 and B is equal to 5, or A is equal to 1 and B is equal to 6. Now note that F plus 1, A and B, all these have to be distinct. So we can't have A equal to 2 because that is the value of F. We can't have A is equal to 1 because then it would imply that A is less than F. We can't have A is equal to 3 because then A and F plus 1 will be the same, but we need all of them to be distinct. So the case that F is equal to 2 can be ruled out. So the only possibility is that F is equal to 1, in which case F plus 1 is equal to 2 and A plus B is equal to 13. Here we have many possibilities for A and B. A and B both have to be greater than F, A and B both have to be greater than F plus 1. So here we can have A is equal to 3, A can equal 4, A can equal 5, A can equal 6 and A can equal 7 and so on. So, but we know for sure that F is equal to 1 and F plus 1 is equal to 2, and we know that there are 5 people with the Erdős number of F plus 1. Now let us go ahead and look at the next clue that is given. On the 5th day, E co-authored a paper with F which reduced the group's average number by 0.5. This is again important because after writing a paper, if the average of the group has decreased, it would imply that the Erdős number of E itself has decreased. And what will the Erdős number of E be after he has written a paper with F? It would become F plus 1. Now once it has become F plus 1, we are also given that the Erdős number of the remaining 6 hasn't changed by writing this paper. So now we can easily calculate what is the value of A and B. We know that the average value of the group has decreased by 0.5. That is, there are 4 people, there are 8 people, and if their average has decreased by 0.5, the value of decrease is 4. Now we know that finally, after writing the paper on the 5th day, the Erdős number of E is F plus 1, because F is 1, F plus 1 is equal to 2. This is after the Erdős number of E has decreased by 4. So initially the Erdős number of E is equal to 6, that is 1 of A and B is equal to 6. If we assume that A is equal to 6, it would imply that B is equal to 7. No other paper was written during the conference. So let us just summarize what all we have found out. What we have found out is that there are 8 people, A, B, C, D, E, F, G and H. We know that some of them have written papers during the conference. So this is just to avoid confusion before we go ahead and solve the questions. Now the first column is their name. The second column is their Erdős number before the conference has started. The third column is their Erdős number after the 3rd day. And the fourth column is their Erdős number after the 5th day. This is before the conference started. A is infinity, F is 1. This is after 3rd day and this is after 5th day. After 5th day, E has a Erdős number of 2. After the 3rd day, C and A have a Erdős number of 2. F will remain 1 each. Now E initially had a Erdős number of 6, so there are 2 6. What else do we know? We know that after the 3rd day there were 5 2s, but because A and C had 2 after the 3rd day, initially there were 3 2s, and after the 5th day there are 6 2s because E also joined the 2 club. So this is basically the information that we have. Now we can go ahead and solve the questions that follow. The person having the largest Erdős number at the end of the conference must have an Erdős number of. Remember that we got A plus B is equal to 6, A is equal to 13, and we found out that A is equal to 6. This A represented the Erdős number of E, so B is equal to 7. This clearly is the highest at the end of the conference because we know that at the end of the 3rd day we had one guy, that is F, who had 1. We had 5 people who had an Erdős number of 2, and then we had 2 other guys who had an Erdős number of 6 and 7. But after the 5th day, the person with the Erdős number of 6, that is E, also became 2. So there are 6 have been accounted for, and there is only one person remaining, and that person had an Erdős number of 7. So the maximum Erdős number of the person at the end of the conference is 7. Let us look at the next question. How many participants in the conference did not change their Erdős number during the conference? So the people who did not change the Erdős number during the conference is F. The people who changed, we can write over here. The people who changed is A changed, C changed, and E changed. Other than these three, none of the other guys have changed their Erdős number. A and C changed their Erdős number after the third day, and E changed the Erdős number after the fifth day. So the number of people who did not change is 5. The Erdős number of C at the end of the conference, the Erdős number of C is 2 at the end of the conference. This is just 1 greater than F, and he wrote a paper with F on the third day, because of which his Erdős number has decreased. The Erdős number of E at the beginning of the conference was, the Erdős number of E at the beginning of the conference was 6. Remember what we discussed? At the end of the third day, again, we had one guy with 1. We had 2 guys, we have 5 guys with Erdős number of 5. We had one guy with an Erdős number of 6, this was E. And we had one guy with an Erdős number of 7. We don't know who this is. Even all the 5 people who had an Erdős number of 2, we don't know. We just know that A and C were 2 of the 5 guys. There are 3 other guys, we don't know who they are. And F had an Erdős number of 1 at the beginning of the conference. This is what we know. How many participants had the same Erdős number at the beginning of the conference? So we remember earlier, again as we have discussed, there were 5 people who had an Erdős number of 2 and the others were distinct. Now at the beginning of the conference there were 3 guys. The 2 guys who became 2 after the third day were A and C, and E also had an Erdős number of 2 on the 5th day. So then we had 6 people who had 2, the Erdős number of 2. But if you remember these 3 of them, there were 3 people who had an Erdős number of 2 at the beginning of the conference. They were the only guys who had the same Erdős number. So the correct answer is 3.
Want to know how 100% Tyler approaches the CAT exam? Now you can. Cracku is giving away 3 full-length mocks designed by 5x 100% Tyler, Maruti sir himself, to mirror the actual test. After you finish, just don't look at your scores. Dive into our detailed video solution for every question to learn the expert strategy. Plus, get a deep performance analysis to pinpoint your exact weaknesses. Get your free mock right now. Go to Google and search Cracku CAT free mock.